Hello everyone. In this video, we will see how we draw graph of derivative function if we know the graph of fx function. So to do this, first we have to understand few point from the graph of fx that we will use to draw the graph of f prime x. So here I list some point that you have to first understand from the graph of fx. Suppose we have a function fx on the interval ab. This interval can be length of infinity. I mean 1 of AB can be infinity or negative infinity, right? Now what we want? We want to draw the graph of f prime x. Okay, already you have the graph of fx, right? Now the derivative of a function means what? At a point, the derivative of a function at a point means the slope of the tangent line at that point, right? So we'll keep in our mind that thing, right? While we draw the graph. Perfect. Now what we see, first we will see, in the graph of fx, do we have any point where the tangent line is horizontal? If yes, then you first point out it. So for example, what I take here this graph, we have some point on the graph where the tangent line are the horizontal line. So at that point derivative will be 0, right? So here exactly you can see that at this point the tangent line is horizontal line. So at negative 3, the derivative is 0. Similarly, at negative 2, derivative is 0. At negative 1, derivative is 0. At 0, derivative is 0, right? There is no other point where derivative will be 0. So at negative 3, negative 2, negative 1 and 0, the derivative of the function is 0 because the tangent line at those points are horizontal line. Okay, so we check the first point where the derivative is 0, means tangent line horizontal. Next, what you do, you will check, do you have any vertical asymptote? So asymptote means the curve will be very close to that line, vertical line. Okay, so if you look at here if you see that, the curve is very close to the line x equal to negative 4, right? So at x, so the curve is very close to the line x equal to negative 4. When you take x very close to negative 4, from the right side the graph become close to the line x equal to negative 4. So x equal to negative 4 is a vertical asymptote. That first you write down that it is a vertical asymptote. Okay. Now if this at negative 4 you have a vertical asymptote, so that will play important role in our graph of derivative function. So how it works? So you have to now check, how the derivative will behave near negative 4. So that how you decide will be either infinity or negative infinity. How do you decide that? So derivative near negative 4 will be infinity if your f function is increasing near negative 4, and it will be negative infinity if f function is decreasing near negative 4. So in our case you see that the function that we have is a decreasing function, right? So you see that the function is decreases. So in our case our limit will be, I mean the f prime x will tend to negative infinity when x tends to negative 4. So in our case what we get? We get that the f prime x will tends to negative infinity as x tend to negative 4 from right side. So I put a plus sign here for convenience, right? To indicate, to mention that I am taking x from the right side. The left side of negative 4 there is no graph of the function, so you have to focus only left right side of negative 4. So negative 4 to infinity is the domain of the function in this case, right? Okay, so this way if you have any vertical asymptote, you can check the behavior of the derivative function near that vertical asymptote. Exactly, I did it for negative 4. There is no more vertical asymptote, right? Now what we see, the horizontal asymptote. If a function, the graph that you have here, any horizontal asymptote you have, horizontal asymptote means if you find any horizontal line such that the graph will be very close to that horizontal line as you make x infinity or x negative infinity. In this case you can see that this part actually make very close to the x-axis. X-axis is a horizontal line as you go x tend to infinity, right? So we have a horizontal, the asymptote. So we can see that, if we take x tend to infinity, then the graph coincident with the x-axis, means touch the x-axis, and it is the horizontal line. Mean the at infinity, at infinity what you get, the derivative at infinity will be 0. You can think like that, at infinity the tangent line is a horizontal line, right? So therefore at prime infinity is 0. So we did for vertical asymptote, for horizontal asymptote. There is no more horizontal asymptote, so only one horizontal asymptote we have. So that's why I did it, right? So this is the right side behavior of the function. Now if you look at here, if you have on the graph, if you have some part of straight line, for example, this is a part of straight line, right? It is a straight line. So here the derivative will constant always, right? Maybe if you take this side, let's say this side is this side is called, let's say 1, this side I call, let's say 4, right? So this has coordinate, these 2 points you join and get this straight line. So here this point have coordinates, so 2 points you join, basically this point, 1 point is this is basically 1 comma 1, and this is basically 2 comma 4. So you have point 1 comma 1 and 2 comma 4. Then you get slope, right? From here the slope will be 4 minus 1 over 2 minus 1. So basically 3. So the line segment on the interval 1 to 2 has slope 3. So in this case what we get? We get that since on the interval 1 to 2 the function is a line segment, so the derivative will be a constant. It is exactly the constant function given by the slope of the line segment. So it is pretty clear that on interval 1 to 2 the derivative is constant 3, right? Okay, great. Now the point that 6, if the function is not continuous or have corner at some point x equal to a, then the derivative function will have pole or jump at point. Now look at the graph. Do you have any discontinuity point here? No. In this graph we have no discontinuity, but we have corner, right? So you can see that here you have corner, here you have corner. Those are the corner. So at corner point, we know derivative will not exist. So in our case, what we get? The derivative f prime of x not exist, right? At 2 point, at x equal to 1 and x equal to 2, right? That's all, right? So we get all information about the derivative function. Algebraically at least we get from the graph of fx. Roughly we get it. Now what should we do? So here you have negative 4, you can see that, right? Now we check the sign of f prime. Look at here. We know at negative 4, f of negative 4 is basically negative infinity, right? We get it. I explained that already. So here you can see that. Now at infinity, end point at infinity, the function derivative function will take value 0 because the horizontal asymptote you have. Now what happened in between negative 4 to negative infinity, in between that? So we split the interval into sub-interval by using the point where you have horizontal tangent line, or maybe derivative is 0, or the point where derivative not exists. So basically negative 3, negative 2, negative 1, 0 and 1. So we have 1, 2, 3, 4, 5, 6 sub-interval. On those sub-interval we check the sign of derivative function. So we know the derivative is positive if the function is increasing. The derivative will negative if the function is decreasing, right? So in this case, if you look at negative 4 to negative 3, it is decreasing function. So therefore, that will take the negative sign. So here negative, 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 right? And here adds negative 3 taking 0, right? And then negative 2 to negative 3, it is increasing, so taking positive sign, right? Derivative, and here 0. Then negative 2 to negative 1 decreasing, so negative value, taking negative value, and here 0, right? And then what happened from negative 1 to 0, it is increasing, so taking positive value, but and 0, it is 0, right? So see now what happened. So now what happened at 1, right? Also we have issue at point 2. So we have to. So now at 1 derivative not exist. So that I put here d and e. D and e mean does not exist, right? But from 0 to 1 function is decreasing, so taking negative, right? and from 1 to 2 it is increasing, so positive value, right? And at 2 d and e does not exist. And what happened after 2? It is decreasing function, so taking negative value, right? So this line will help you, the line with the sign of f prime x will help us to draw the graph of derivative function. So how do we do it? So first, what should we plot? The point first we indicate where derivative is 0. So at negative 3, derivative is 0, right? And at negative 2, derivative is 0. And negative 1, derivative 0. And 0, derivative 0, right? Now, I'm just putting box where derivative not exists. At this point 1, derivative not exist. At the point 2, not, does not exist, right? So the dot, the bold dot that I put, the derivative function will be 0 there. And the box where I put, derivative not exist, right? So as I know that, so here at negative 3, derivative function is 0, right? So we have to start from here. Now what happened to the left side of negative 3? As we know, the f of negative 4, where I wrote that, you can see that, so one thing, negative 4 to negative 3 function, derivative function taking negative sign. So from here we have to go down and go dot 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 and up to negative infinity, because at negative 4 function taking value negative infinity. I'm going to draw the rough graph. Now negative 3 to negative 2, what you have? It taking the positive sign. So we have to draw the graph of derivative function above x-axis, but we have to make at negative 2 0. So you have to make a term here. At some place you have to make a term. I don't know where, but you have a term, right? So then 0. Back to negative 2 here, derivative function. Now from negative 2 to negative 1, taking negative value, but at negative 1 you have to make 0, right? So go negative and you have to make a term and you go back to here. Okay. Now negative 1 to 0 taking positive value, but at 0 again 0, right? So you have to go taking positive value, but you have to make a term here. Okay. Perfect. Now what happened 0 to 1, right? Look at that 1 you have issue, right? And 0 to 1 taking negative value. So I don't know what you take. So basically you have to go to this. I don't know how much negative value, maybe this. So you have a hole here, right? Because we don't know, right? Okay, great. Now 1 to 2, as I mentioned, at 1 to 2, it is a constant function, line segment 3. So 1 to 2, it will take value 3, right? So at 1 to 2, 3. So at 1 to 2, 3. So at height 3, I draw a line at height 3. So this is my height 3, right? This is the part of the graph. So see, at 1 you have jumped from here to here for the derivative function. Now what happened after 2, right? If you look at 2 here, then you see that the function will take negative value. See the negative value. So you have to make a jump at 2. Maybe I don't know when. So you have to guess what is the slope here, right? So in this case, it will be a negative slope. Maybe hopefully I am drawing here. So maybe this way, and it goes way like this, and it's very close to 0. Yeah, this is the graph for the derivative function. So this is the graph of f prime x. Okay. I hope you understand. In this example, I try to consider all possible cases. Hopefully, all you understand this. So, if you have a graph of fx function, then first what you do, you will just list out this all information and draw like this a line and use this line to draw the graph of derivative function. Okay. Hopefully, all you understand this concept. Thank you so much. See you in the next video.